Lots of people have been catnipped by Cloud Code. None of us can sleep anymore. Peter and Armin are on 3 and 4 hours of sleep a day. Same for me. Cloud Code's been an interesting experience in that it's the first coding agent that feels like it actually allows us to do things we couldn't do before. And it's not so much about the tool being a better programmer. It's definitely not. It shits out real bad code. But it lets us iterate on ideas we have at a speed that wasn't possible before. This means that we can play around with ideas with a super fast turnaround time. And if we find something that sticks, we can actually make it pretty by using our human brains and relying less on Cloud Code. At least that's how I approach things. Armin gave a talk recently. He is a little bit less of a dictator in that sense. I think he has a pretty long leash around Cloud Code's neck. I'm more of a control freak, and I really don't like it going off on its own for too long, because I find that I usually end up with a big mess of over-engineered tech debt. Anyways, the point of this talk is to give you a practical insight of how I use Cloud Code. It's not an engineering discipline yet. I think we're all struggling to find the patterns that will make things reproducible. That's one big problem with agentic coding. You're talking to an indeterministic machine or model, and results may vary depending on how you prompt it. A single word in your prompt can actually change the outcome entirely. Despite all of that, I'm going to try to show you practical applications of Cloud Code outside of coding for new projects and for using it with established code bases. So I'll be exclusively mostly talking about Cloud Code, so I assume basic familiarity on your end. If not, head over to the website, read the docs, get yourself familiar, play around with it, let it generate a little game or whatever you're comfortable with inspecting and playing around with. And once you're back, use this, Elias. Now people will scream at you. This basically passes a flag to Claude that tells it to skip all permission dialogues. We want to use Claude in a way that it doesn't ask for permission all the time or doesn't ask you to input more information or whatever. So skipping those permission dialogues is a way to happiness because Claude is very, let's say, ASCII. It will pop up those permission dialogues all the freaking time. If you do not do this, you will end up in a situation like this. Let me just first clear any previous permission I gave. /commands, also very important, but read the docs. In any case, I just recorded a video in this directory, the intro video, and this is a MOF, so I want that to be converted to FFmpeg. I don't remember anything about FFmpeg anymore, so I'm just gonna ask Claude to do it for me. Hey, could you please convert the MOV file in desktop-talk into an MP4 using FFmpeg? Set a big timeout because this could take a while. So what Claude is now doing is it basically comes up with a bash command to do exactly that. And that will usually ask for permission, like this. And for some of these commands, it allows you to pick the second option, which is yes and don't ask again, which will set up a permission rule that allows FFmpeg in that directory to be executed in the future. In some cases, it doesn't give you this permission, but will ask you all the time, yes or no. And the reason for that is that in the background, Claude is actually passing the bash command it's about to execute to Haiku 3.5 with a very simple prompt that essentially boils down to, is this dangerous? Does this require user permission asking all the time? And if Haiku 3.5 says, yep, this is super fucking dangerous, you need to ask the user about this every fucking time, then you don't get option 2. And the way I figured that out, I'll show you in the next part, but let's just say it's very funny. So anyways, this is annoying and this will break the loop. By loop, I mean you give Claude a task with a hopefully pretty good specification and it will do the needful for as long as it takes until it finishes the task. And if we have these permission dialogues, then we as the humans need to jump in all the time, and it's very fucking annoying. So anyways, if we do the same thing with Claude Danger, it's not gonna happen. It will still tell you that you're now trying to access things outside of the working directory, because by default, Claude will try to cd into the directory and then use local relative bash commands. It usually figures out how to do it from your current working directory. And it's still annoying because it wastes turns, that is back and forth between your local client and the LLM in the cloud. But generally it will eventually arrive at a solution. And that is Claude Danger. I haven't had anything bad happen to my machine in 2 months. There's nothing on this machine that could be leaked or that could be destroyed. Everything's backed up in the cloud. So even if Claude fucked up, I would not care. I would just wipe the machine. It probably wouldn't install a rootkit, so I assume it's pretty safe to just wipe the machine if something bad happens. And if you're super extra mega concerned that Claude will do something to your machine, just run it in a Docker container or any any container of your liking, really. In 2 months, nothing bad happened, so take that with a grain of salt. What it does fuck up a lot is Git commands, especially if the project becomes bigger and if the Git history becomes a little bit more complex, or your staged files and working directory are a little weird or outside the norm. But yeah, other than that, nothing bad happened so far. Famous last words. Another thing you'll read in the docs is about Claude MD files. And Claude MD files are basically just a way to inject additional information into the system prompt that Claude comes with by default. There are multiple locations you can put these files. For example, I have a very simple one in my user directory, which just tells it to don't add comments and never add yourself as a committer and never add this silly line to your commit messages. This will get appended to the system prompt, which is passed to each request to the LLM along with the history you have, the chat history. And it generally doesn't work. Like Claude has a really strong tendency to use grep instead of rip grep. And it's fucking annoying because on macOS grep is just kind of broken. So yeah, this is nice if it works, but often it doesn't work and you cannot rely on it working. In addition to your kind of global Claude MD, you can also have Claude MDs in any folder of your working directory. And if you spawn Claude in this directory, like we did here, it will read the one in user directory and this one. And as you can see here in this one, it's kind of basically a description of the project. This is my blog. My blog works using my static templating blog engine thing, which has a watch mode and basically takes whatever is in source and outputs HTML. The sources are freeform. You can do whatever you want. There's a little JavaScript-based templating engine here where you can execute any kind of code to generate outputs. It's basically like PHP, just with Node. Yeah, and what I did in this Claude MD is I describe to Claude what this directory is about, where to find things, how to execute things. Pretty simple stuff. The takeaway here is that Claude is not just for code. Claude is a general purpose bash bash command calling machine. And it's really good at it, especially if you give it concrete instructions. So in this case, let's see, we can just demonstrate how well this works. Let's say I want to write a blog post, which is basically about what I'm recording now. So agentic coding, or whatever you want to call it, throwing shit at a wall and hoping it sticks, for example. So I can just tell Claude, hey Claude, I'd like to write a new blog post dated with today, June 29th, 2025. And its title should be How I Claude Code. And the slug should be just Claude-code. Please set that up for me and then start the server. So it will now read these instructions, which tell it how to create a new blog post and how to set up the server, and will dutifully follow all of that. So it already fucked up by not using the correct directory, because we said June, but it made it January, which is very not good. And then it writes the basic meta.json, which is just a description of the blog post that the generator uses to build this table of contents, basically. It started the server, which runs in watch mode, so anytime I change this here and save hello, this will auto-update, which is very nice if you're working on more visual stuff in the blog post. And we're more or less happy. I said June, not January. And that should be enough for Claude to understand that it should change this to the proper date. The question is if it reopens this. It probably doesn't, but it's not a big deal. Oh yeah, now it keeps reading this and also modifying the meta.json, which also has the publication date in it. And it actually reloaded the correct URL. So takeaway here is Claude is not just for code. Claude is for anything that you can bash. It's also really good at writing ad hoc scripts. You just saw me previously trying to convert that one single file into that one single MOF file into an MP4 through FFmpeg. Instead of asking Claude to do this all the time for a specific file, I can just say, hey Claude, could you please write a bash script and store it in desktop /talk? It should run through all the MOF files in that directory and convert them to MP4 using FFmpeg. And for me, this is where Claude shines, actually. I use this all the time to write these kinds of ad hoc scripts and tools, either using bash or Node, because it makes my life so much easier. Sometimes if something reusable comes out of that, I just put that in a location in my path and keep using it for the rest of my life. I think I previously had one of these convert MOF to MP4s, but I might have just, I don't know, deleted it. So now let's see if this actually works. Obviously it will, because it's pretty trivial demand for a machine like Claude. And it even set the permissions, and it seems to work just fine. Yeah. And this doesn't extend to just these kinds of simple tasks. It can also do data analysis for you. Basically run through this directory recursively and do the thing. Read the Excel sheets and extract this and that data, or summarize the contents of all of these PDF files and write that out to a JSON file with metadata and the summary and so on and so forth. And those are all just ad hoc. This is nothing I would actually inspect and modify myself. I just use them 1 or 2 times for a specific task at hand and then throw them away and take the results and work with that. And it's really great at that. And it takes a while to get into the state of mind to actually realize that Claude is so good at that. I often find myself writing something by hand, or just keep asking Claude to do this one thing repeatedly instead of kind of making it more general and putting it in a script. Really watch out for any kind of automations you can have Claude generate for you. It's super fucking practical, and it will save you so much time. And once you have tools like that, some little scripts that you actually want to reuse and that aren't just one-offs, put them in your Claude MD for that specific project. In most of my projects, I have a script folder, and all of these little ad hoc tools go in there. And I also let Claude put descriptions of these tools in my Claude MD. Actually, I'm not using Claude MD all that much anymore. There's a reason for that, but we'll come to that later. Anyways, takeaway, Claude's really good at not only calling tools, but also writing tools for you. And you should use that. They don't have to be programming specific. Anything that you can bash should be abstracted like that, I think. Claude is not only good at calling tools and writing tools for you that are ad hoc in form of bash or node scripts. It's also pretty good at figuring out the structure of a project. It has to, because otherwise it couldn't help you. The problem with that is that every time you start a new Claude session, like this, and then ask it to do a thing like this, Please create a new blog post dated 2025-06-29. It should be called How I Do Stuff, and please generate a good slug for that. Then what it needs to do is it needs to go off and basically investigate your entire project. That's not nice. You don't want to waste time on this. Also, every time Claude does this, it might come to a different conclusion. Every single word in your initial prompt will trigger a different path in the LLM weights. So what it does is not necessarily reproducible. So instead of doing it the cowboy way, it makes sense to write down what the project is about and how it's structured and what the common tasks are and how to achieve them or perform them. In this case, it ended up writing the meta.json, which looks okay. It ended up writing an MD file, which misses the very important PHP-like scripting stuff that adds the footer and the header and includes the meta.json and so on. But it did create, it actually also, it created the correct folder name. So all of that is fine, but it's wonky. It's not quite right. And having to go in there and fixing it up every time sucks. Also, it wastes context because all of this is no part of your context, which means you have all of this nice garbage in here. Press Ctrl R, Ctrl E. Well, in this case, it's not that much, but it piles up in more complex projects. So instead, what we had and want to generate a new is a nice little Claude MD file that describes what it's about and the tasks and how to do them. Also, any kind of rules like coding rules, CSS styling rules, whatever you have. We could write this by hand, or we could have Claude generate a first draft. And the way we can do this is like this. So please note I have, let me delete this. I have deleted the README-MD and the Claude MD I had previously. This is the old Claude MD. We can compare against later on. So it doesn't cheat, right? And then I just go super ad hoc. Please analyze this project, read the publish.sh file in full, and then read a bunch of files in the source folder. I then want you to write a Claude MD file that details what the project is about, its structure, and common tasks you think will be performed. Please keep the Claude MD nice and minimal, yet exhaustive. So this will trigger essentially the same workflow or steps that Claude took when it wrote our blog post ad hoc earlier in the last session, except this time it won't actually execute any of that stuff. It will just take note of things and write it down in a new Claude.md file, which is nice because the next time we start the session, Claude will automatically load that Claude.md file and immediately know what we're about to do or how we are going to achieve what we're about to do. And you want that, not only for a very simple project like this blog, you want that for your biggest super modular whatever projects as well. And the way you go about that is pretty similar to this, except you won't put that all in a Claude MD file because it's going to be huge. You want to split it up. The way I usually do it is I have a docs folder in my repository. I have an spec.md file, which gives a general overview of the architecture and any submodules. And then for each submodule, I have a specific MD file that the spec file links to. If I then want to work on a specific submodule, I'll tell Claude to either just read that submodule MD file or multiple, depending if I need to cross-reference other modules as well. And that makes for much less turns because Claude will not waste time crapping and failing through your code base anymore. And it also serves as fantastic documentation. What you then need to do is keep that documentation up to date. And good news, Claude can help you with that. So anytime you modify a module in your project, just have Claude analyze the final Git diff and then update the respective MD file for that module to be in sync with the actual sources. This might sound cumbersome, and you still have to go through the changed MD file by hand and make sure that it actually does cover the changes properly instead of hallucinating shit. But it will save you a lot of turns, a lot of time, and a lot of grief down the road because it also serves as documentation for you, the human, which is a point we'll talk about later. So did it generate a Claude MD file? It did. And now we can compare it to our old way of doing this. So in the beginning, this is pretty much the same thing. Project structure with a bunch of files. I would probably delete it. Common tasks, add a new blog post. So create the directory, that makes sense. Add the meta JSON, that is also okay. And then write content in indexMD. This one is tough. It failed to identify that indexMD needs front matter using the templating engine, this stuff here. We're gonna fix that. And then add media files to media subdirectory. To build the site, yeah, that's correct. To deploy, that also is correct. Preview locally, open, this is not correct. So it also didn't actually execute blark with --help to figure out that there's a development mode. So instead of going in there and writing this by hand, I can just tell it. So the way to preview locally or development mode should be to invoke blark with the --watch and --serve arguments. And you should use no-hub for that, so it doesn't block you. And also, when you write the initial index.md, it needs to have EJS front matter. Please look into the other indexMDs, how that works. Once you've figured out all of these things, please update the Claude.md. And this is essentially how I can also trigger a rebuild or an update of, say, a module.md file in docs folder that I talked about earlier. So as you can see, it now executes blark --help. It looks into the front matter of other existing blog posts, and it should update this nicely. Again, the MD files that Claude generates for you, treat them as first drafts. Do not take them as is. They will have errors, like we just saw, or missing things, and you need to make sure that they are golden, because those are the ground truth for every session you start with Claude. If you're lazy and do not do this, then you will end up in a world of hurt. It also benefits you, because one of the things I see a lot of people doing when they use Claude Code or any other agentic vibe coding tool, they just let it shit out an immense amount of code, never review that, and just go by the manual testing. That's not the way to do it. At least that's not the way I do it, because I like software that works, and I like software that I can maintain even if my internet is down or my Max subscription actually got rate limited. So it's important to understand things. And this is a very nice way to keep track of things. Even if you don't fully crock every single line of your vibe coded stuff, this at least gives you a chance to also work on this and debug things on your own. And it updated things nicely. There we go. Do this. It's really important. You need to understand your code. So now we have our new Claude MD, and I guess we could just test it. I'm starting up a new session, and then I say basically the same thing we had before. Let's see. Actually, let's use resume, which is a very wonky way to go through all your previous sessions. I'm still not sure what the sorting of this is. It's very not good. But yeah, it's supposed to let you resume old sessions with Claude Code. If one of these sessions gets compacted, the summary is all fucked up. Again, the sorting is all kinds of fucked up. Yeah. Purpose of this is I want to actually just replay this session. As you can see, this one where it didn't have any information about the project. And now try it with a new and improved Claude MD file. So please create it should be called on. Please create a good slug for that. Actually, let's add more in. I also want you to start the dev server and open the new blog post in the browser. And now compared to the old way of unstructured exploration and then kind of sort of doing the thing, the hope is that Claude, based on the Claude MD, is now able to do this in one go. It might, in this case, not be faster because the task is pretty simple, but it's more structured and repeatable. And it will pretty much do the same thing every time you ask it to do this. So it writes the new meta JSON, which is fine. Publish true is probably not what we want, so this is another opportunity to make Claude.md better. And then it creates the index.md file, which takes a lot of tokens apparently. I still don't know what the little hammers mean. Let's see. Yeah, now this time it added the front matter, and I don't know what this is. It just hallucinated an entire blog post. I guess that's where all the frat boys get their content from. And finally it starts the development server with no hub. It sleeps for whatever reason. I guess it doesn't trust my code. And opens the blog post in the browser, hopefully correctly. There we go. Yeah, I wish they had something like time management, then I could sleep. Anyways, takeaway. Use Claude to write documentation for your next Claude session and yourself. Never take the first draft of that stuff as gospel. Manually go in there, make it nice, make it pretty, make it adhere to the actual structure of your project, and then keep updating it every time you change something. Sounds tedious? Totally fucking worth it. Quick step back here. How did we get here? Why are we all so sleepless? Let's look at the evolution of LLM-based coding assistants. In the beginning, there was GPT, which wasn't really good for coding, but it gave us a glimpse into the future. Then came GPT 3.5 and Codex and GitHub Copilot. And the way we used that back then, us old graybeards, was we set up a little project like this here. Opens a window, allocates a pixel buffer, clears the pixel buffer to a nice blue color, then enters a main loop where we update the window with the buffer contents and wait for the app to exit. That's it, right? Uses MiniFB, super awesome library. Love it. The person who built it is a demo singer. He's a lovely person. Love everything about it. Clear and simple. Implementation also super clean. Anyways, we have this little project and now I want to draw a line. I know my computer graphics, so I want a Bresenham line algorithm, but I don't want to code it myself. With GPT 3.5, I would do this. Paste all the things in here and say, please add a line drawing function using Bresenham's algorithm, then modify the main loop to render 2 lines. And this was good and this was well. We could basically, minus the system prompt, specify what we have in our context and be pretty happy with the results. And then we would wait for that and wait for that and wait for that. And then we would just press the little copy button, go back over here to our editor, paste, see that it still kind of compiles, and we can try to run it. Oh my God, what's it doing? There we go. One more time, baby. Yeah. So this looks good. Kind of, sort of. But it doesn't scale. But it has the big benefit of me being able to mostly, minus the system prompt, control the context. So I know exactly what information the model got to generate its answer. And that's nice. I like that. Then Microsoft and OpenAI and GitHub teamed up and built something called GitHub Copilot. And I remember Nat Friedman being mad at me because I wouldn't understand why this was the future of coding. Because honestly, I still to this day think this is not the future of coding. So the way GitHub Copilot worked was, it was a completion model, basically. You write a comment and you say, tap, tap, tap. Oh, Jesus, it untapped it. No, I want to keep this, please. So, good. Oh, Jesus, cursor. Bresenham line drawing algorithm. Right, so you write out that comment and then you just tap and tap and tap. And eventually it will start fucking up your code. And at some point recover, hopefully. And then it deletes a bunch of stuff. Oh my God. And tab. And now I don't have buffer clearing anymore. And this is all very terrible. But it again compiles. But I now have a black background, I guess. Oh, no, I don't. Did it? Oh, it's still in here. Oh, it does it every iteration. Okay, anyways. Yeah, as you can see, this is terrible. Also, this doesn't scale. Also, and the biggest problem, again, it doesn't scale like copy and paste also doesn't scale. But the problem with this is, apart from the shitty UX, I don't control my context anymore. I don't know what's being sent to the model when it generates me these partial completions. And that's bad, because I like to be in control of that. Having worked on production LLM-based systems, I want full control over my context because I, as an educated person, know that context management is everything. And Copilot didn't give me that. All right. Shitty UX, right? And copy and paste, not ideal. Some kids in Silicon Valley then figured out that they can actually fork VS Code instead of writing an extension and build things like Cursor or Windsurf or whatever other gazillion IDE VS Code forks we now have. And the way this worked was a little better. It was basically an improvement. Oh my God. It was an improvement on the copy and paste workflow that you had with GPT 3.5. So you'd open your workspace in your VS Code fork. You would open a file and you would want to modify that file. You pull up the chat window here, and the wonderful IDE fork will add this file as context for you automatically. And then you go ahead and just prompt it like before. Please add a line rendering function using Bressenham's algorithm, then modify the main loop to render 2 lines. And in the old days, we had this mode, which was basically just a nicer way of the copy and paste workflow we had here, plus the automatic additions of the open file, plus, and this is where the problems start, some background bullshit where it would actually not submit the entire file, but cut it up, then also pull in additional bits and pieces from around the code base without you having any kind of control of the context that's being submitted for this request or for this turn. And that sucks. I hate it. Again, just like with Copilot, I need to be in control of the context because that also allows me to create more complex workflows that actually work and are repeatable. Cursor, the old mode, didn't give me that. Don't know if the agentic mode is any better. I doubt it. The reason being that Cursor is in the business of basically making a margin between you paying them and them paying someone else for tokens. So their goal must be to reduce the amount of tokens that they send and receive from the LLM provider, which means they need to fuck with your context. You have no control of it. And I like that. So Cursor is not ideal, but it's an improved workflow compared to copy and paste. This UI is also really nice. I get to see the changes the LLM suggests, and I can just accept them, blindly run without debugging. And this is very awesome. And for the past year, I used this, but always with the thought in the back of my mind, I don't control my context and I don't know what the fuck Cursor is doing, but it's probably not good. And it's probably the reason why this fails on much more complex tasks than this simple demo here. So, and then Anthropic decided to publish an internal tool. And that internal tool came with a bunch of stuff that is really nice. The first thing it comes with is, for plebs like us, a subscription. And that subscription is a max subscription, which costs you about $100 a month or $200 a month for an insanely high amount of tokens that you can exchange before you get rate limited. Now, some people manage to do that with the max account at $200, like Peter Steinberger. I don't, because I keep my LLMs on a tight leash, and I usually don't run more than 2 or 3 of them in parallel. For me personally, the max plan is unlimited usage, which is great. And unlimited usage means Anthropic doesn't in the background need to save tokens. So there's no context size reduction tricks like Cursor and other non-LLM providers have to rely on to make a margin. And this is the first part to this equation. Unlimited access to excellent coding models without any context fuckery. And the second big thing is that the Claude Code comes with built-in tools, which we'll look at in more detail in the next section, which actually allow the thing to loop, which means give it a task and some success criteria, and it will do its damnedest and not stop until it has reached the success state. And while Cursor, probably in agent mode, can do this for you, it usually breaks. It just doesn't continue looping until success state is reached. It just stops. And there's no indication it stopped. No, I can step away from this and come back knowing that it probably finished the task. With Claude Code, that's possible. And the bonus point is that I mostly get to control my, my context. Now, this might not be obvious in the UI, because if we do this, please add a line rendering function using Bresenham's algorithm, then modify the main loop to render 2 lines. The UI doesn't show you all the things that are in the context. Like, it won't show the 38 lines that are being read unless you press Ctrl R, which is nice because now I see what's happening. And I also see the details for the other tool calls, but obviously there's more in the context than this. There's the system prompts, the tool definitions, additional information they hide in the UI. But this is hackable, and we'll look at that in the next section. So we can better control and understand how context is being built up and managed by Claude Code. And all of these things together, basically unlimited tokens, at least for me, at a low price. And tools that actually work, and context management I can do myself for reliable workflows is what makes Claude Code so damn fucking good. So I was babbling on and on about context and context management a lot, and we already saw that Claude Code in its TUI doesn't really show us all of the context, but it's hackable. So I wrote a little tool. It's called Claude Trace. You can install it globally like I have, or just run it via npx. And the thing this tool does is it starts Claude, it injects itself, it hooks the fetch node function, and then just logs all the requests that Claude makes through the fetch function, which is very funny. So I can do an include all requests here, so I get to see all the things in the log. And let's go, let's start it. Okay, the first thing that happens is it creates a .claude-tracing folder, and then it logs the raw requests and responses in there. And from this raw response requests, I reconstruct a nicer HTML version of this, which we'll see in a bit. So let me close this down. And actually, we haven't submitted anything yet, right? So let's just close this, and ta-da, there's actually something going on here. So it turns out that in order to get a quota, Claude Code will fire off a message to Haiku saying quota, limiting the max tokens to 1. And it doesn't matter what the reply here is. What matters is this here. And I hope I didn't leak any keys. I think Claude Trace is smart enough to not actually show the key. Yeah, it actually doesn't. Okay, good. So anyways, this is how they check for quota. They actually ask a silly question to Haiku and trigger a full LLM inference to get basically this, instead of having a dedicated endpoint. Now that's funny, right? Okay, good. So let's do this again, and dangerously skip permissions. I hope I got that right. And then ask Claude to, I don't know, implement circle rendering using Bresenham's circle rendering algorithm. Please implement another function, draw circle, that implements circle rendering using Bresenham's circle rendering algorithm, and then modify the main loop to draw 2 circles. Okay, and we're gonna let it work for a little while here. Because the next thing we're gonna look at is what actually happens to a context when this is executed, right? So I told you Control R actually gives you a pretty good idea what's in your context, but it's not the full truth. And it's rather interesting to see what's actually happening. Hey, I said skip. Oh. All right, I hope it's done soonish so we can quit the session and open up the new log. There we go. So we're done doing this. I'm not sure if it runs. That's the thing, so that's good. It really likes red and white for some reason. And then let's quit the session, which will open up the latest log. So again, we get the quota call, which is nice. And then we get this here. Do you remember when you... Oh, it's actually something like this. Run with dangerously skip permissions. Claude Trace is a little janky. Right, so when you do anything like read the main.c file, you get these little cute words here, right? So ever wondered how they generate those? Well, wonder no more. They are sending your user request to Haiku with this prompt. Analyze this message and come up with a single positive, cheerful, and delightful verb. And this happens for every token you actually input. So that's cute. Oh, actually, it used to happen for every token you input. I think they might have seen Claude Trace and fixed it, so it's actually only doing it once now. Or my my log output is wrong. I don't know. I remember it doing it for every token that you input in the edit text field. All right, so once that's out of its way, it will actually call into Opus with our request. And it doesn't just send our request. If you have the nice IDE integration, which you cannot install, actually. Let me demonstrate. So I go IDE none. Now we're not connected anymore. I go to extensions and say, please go away. And then I restart. Oopsie. And then I restart Claude. Ta-da! The extension is back. And there's no way to get rid of it. And you will see why I hate it. So I usually do this at the start of my sessions. Anyways, where was my log? There is my log. So it's not just your raw prompt that gets sent as the first message in a conversation. There's also a system reminder, and that would contain your Claude MD file. And there's another one at the bottom that reminds Claude that there's a to-do list that it can use via the tools. And it shouldn't mention this to the users. And this is what the IDE extension, the VS Code extension, the Claude Code VS Code extension spits into your context. And why it's useless is actually inside the message, because it itself says this may or may not be related to the current task. And at least in my workflows, it's usually not related to my tasks. Because while Claude is doing its thing, I open up files from other projects or other submodules and either refactor by hand or do something that's unrelated to the task that Claude is currently working on. This is really annoying. This poisons my context and confuses Claude. But so it is. What's even more interesting is that you get access to the full system prompt. You can run Claude Trace yourself to read it in detail. There's nothing really surprising in there. It's, I suppose, well written. I mean, you would assume that Anthropic people, of all the people, would know how to do this. The more important part is the tools section. And here you get to see what all the tools internally actually do. Which is very nice. Task is super important. We're going to look at that briefly later on. This basically spawns another Claude Code instance, more or less, without all the context that's in your current session. And your main Claude with which you talk will generate a prompt, put it into that sub agent and have it work on it. And in your context, only the result from the task agent will actually pop up. Bash we all know and love because it's so versatile. Club it never uses. Crap it never uses, but it uses the command line crap, and that's crap. ls it sometimes uses. Exit plan mode, I don't care. Read, often used. Problem with that is, we'll see it down below. It doesn't just give back the lines. It also has a 200 line limit. It also has a, I think, 65k token limit or 30k token limit, so you can't read big files. You have to read them in chunks. Edit fails. I have a theory why that is. We'll see later. Multi-edit, barely used. Write, yeah, nothing to say about that. I don't do Jupyter notebooks. Web fetch is funny because this actually doesn't fetch the raw URL, presumably because they don't want prompt injection. So if you ask Claude Code to fetch a random URL and that the content of that URL or behind that URL has a prompt injection, there's a good chance that that prompt injection might trigger Claude Code to extract confidential or sensitive information from your local machine and send it to someplace else. You would see this in the UI, but if you step away from Claude Code and don't look at those logs, congratulations, you just got fucked. So what they do instead is they have an LLM that actually fetches the content, summarizes it, and the summary is given back. So if you think web fetch will actually fetch the raw data from that URL, you're wrong. It does not, and we can demonstrate that. To do read and write, yeah, that's obvious. Same thing as with web fetch. Web search also doesn't give you raw search results or injects raw search results into Claude Code's context. Gives it a summary, which is usually decent, but I barely, if ever, use this. I'd rather have control over what gets injected into my prompt, into my context. So those are things I'm working on at the moment. Big surprise. This is too many tools. I know this is gonna get better. Promise. So we had a look at the first user message, at the tools, which you should read, at the system prompt, which you should read. And then we can look at the assistant messages and the tool calls. So the first thing it was reading main C, issuing that request. And the result of read is what you'd expect, the lines that Claude requested, in this case, the full file. The interesting part here is that it prefixes all the content lines with this. And I just saw that my UTF-8 rendering apparently is broken. In any case, I think this is the reason why Claude gets confused when it actually then writes to that file or updates that file. Because this additional white space from the read tool seems to slip into the edit tool's inputs that Claude generates. And then the edit tool itself needs a perfect match, but it doesn't get a perfect match anymore because Claude has additional white space in the old string and new string. We're going to see that later maybe. And there's also the raw tool call if you want that. So here's the edit call, right? And the way the edit call is done is like this. It just gives the old string and gives the new string, and it needs to match exactly, which includes the white space. And sometimes a little space or a little tab will sneak in here. And I'm pretty sure it's because the read tool prefixes every line in the content with white space. So yeah, nothing really surprising here in the remainder. Use Claude Trace to better understand what's being pushed into your context. So back to context management, there's also one more thing that hits you frequently, and it's the end of the world, or rather the end of your session, which is compacting the conversation. Let's look at what that actually does to your context. Illustrate my problem with compact conversation, which is also your problem. I pulled up a little toy project that's a little bigger than our CMake project. It's called Vibe Tunnel. It's basically a Tmux replacement for the vibe coding age. What it allows you to do is create a terminal session on a host and then use Claude in it. And then when you're on the go, you get a nice mobile interface to interact with your Claudes on mobile and check in on their work. You can find it on Vibe Tunnel AI. It's open source, so good luck. Anyways, back to this. This is the source code. My domain is the web folder. I previously generated a specmd, which is supposed to minimize the amount of turns Claude needs to find things in the code. The way I generated this is in ClaudeMD, and I rerun this every time I change something in this module. So when I start working on something in this module, I first instruct Claude to read the specmd file. And once it has read all of this, it should be able to navigate the codebase a little more efficiently. And then we can start on our task. And the task is that we want to replace the format that's being used to store and stream the standard output of each process on disk. We want to optimize that to be less sucky. Currently we use the cinema format, which is a way to play back ANSI sequences generated by a terminal in some client. As you can see, this is JSON-L. I want this to be binary because it hurts my heart. So, hey, I would like to replace the cinema format we are currently using with a binary format. Please investigate where the format is written and then write me 3 proposals for a binary format. And Cloud Code will probably use a task tool call to do the investigation, or it just reads the cinema writer file, which is the, whoopsie, where is it? Which is the place. Oh yeah, it just reads the cinema writer, which is the place where we write out that format to disk. And then it also reads the front end, which is the cast converter, which gets that content from that file and displays it in the terminal xterm instance. It then analyzes the current format usage and data patterns and veers off into searching stuff again. But hopefully it doesn't take too long to do that. And while it's doing that, I'm gonna plug in my power supply. But as you can see, it doesn't search too often and it directly goes into those files. What it doesn't do well is read the entire fucking file. It just reads them bit by bit, which is not great. And now it tried to access a stream-out file, which no longer exists, which leads me to believe that specmd is outdated. Yep, we still say stream-out is the file that's being written, but it's now called standard-out. Right, so it's done understanding the current format. And now it probably comes up with some terrible binary format proposals. But let's assume we've iterated on that for an hour or so, and the dreaded 10% until compaction pops up down there. What you gonna do? Well, if you miss that point and you run into a compaction, you're in a world of hurt. And we can simulate that with directly invoking the compact command. Come on, spit it out. What's your proposal? I need background music for this video. Okay, so here's the proposal. It wants to turn this, which is a header, plus individual outputs and inputs and resize events, into this magic header, because why not? A version compression. Yeah, that's probably not a good idea for this. Chunk size. Well, I can already tell proposal 1 is garbage. Oh, that was proposal 2. But let's assume we iterated on that. We took that as the first draft and we iterated on that just within this conversation. We didn't store anything to disk. We didn't modify any code. We just iterated on that. And then, bam, compaction happens. So how much of this is actually retained in the compacted conversation? And I can tell you, it will not retain any of these specifics, at least not to a level where you would be confident continuing your work. And that hurts. But there's a way to kind of work around that. It's not perfect and it's project specific, but it generally helps me avoid this bullshit. So let's see. Compacting conversation can also take a long time, which is very annoying. In this case, Cloud Code will at least show us the summary that it actually generated, which is helpful, so we don't need to use Cloud Trace to peek behind the curtains. Sadly though, the default UI will not directly spit that out. It would be helpful. So Control R, and then we see the actual compaction. Blah, 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 blah. It basically summarized what it did. I attempted to read the file. This is all irrelevant, basically. And then the summary, primary request, key technical concepts. Okay, files and code sections. Okay. Where are the proposals? Problem solving, all user message, current work. I don't see the proposals in here anywhere. Oh yeah, here they are. Well, this isn't anything like this, right? So if this was actually handcrafted by you throughout this conversation and you eventually reached a final proposal that you're happy with and that you now want to go implement, well, you're fucked because it's basically gone. Now, in this case, it's not hard to fix. You just look at the last assistant message and copy and paste that. But sometimes that information is spread throughout the entire conversation. So copy and pasting and finding all those bits that you need to retain is really fucking hard. So we can summarize that compact conversation will kill your vibes. You will not be able to recover from this if you don't do it in a controlled way. Now, one way to control it is to invoke compaction manually, and then you can optionally give instructions for summarization. And this is basically a good idea until it's not. And the it's not part is, first, it's hard to come up with the perfect instructions for the summarization one shot. And you only get one shot. If you call compact and you provide super good summarization prompt yourself instead of using the default Claude Code one, and that still fucks up, you're fucked again. The other method is to just press escape twice and go back as far as you can in your session history and try to recover before compaction. So this is the compaction prompt that Claude is sending, and we can just kill that. And then we can do the following. We can say, okay, I want to continue this session. Please write a task-summary.md file and summarize all the important information throughout this conversation regarding the binary protocol proposals that you came up with. Please also write out all the files that are relevant to this task. The goal is to quit this session, create a new session, and read in that task summary file so we can continue our work. And this might look like just using /compact plus custom instructions, but you will see there's some sense to this madness and thinking that you're better than the Anthropic team in prompting. Okay, so now it has written our task summary. And the point of this is that we can compare this before we quit the session with the actual information, either what you can see in the last user message or what you can recall from your own conversation history, so to speak. And we can immediately see that this is not exactly what we want because it didn't summarize the three proposals. It should have just copy and pasted the three proposals into this file, basically. But the thing is, if we do this early enough, if there's still room in the context, we can iterate on this. And this is a much better strategy than using compact with custom instructions. So let's yell at Claude. You didn't retain the binary protocol or binary format proposals. Please update task summary and keep the proposals verbatim. Again, loosey-goosey. We never talked about an implementation plan. So at this point, it basically just made shit up. Maybe it knows it's about to be ended. I still haven't figured out what the little hammers mean. It's not something that's being shown here or anywhere else, really. So yeah, this is closer to what we had before, but it's still not really what it proposed, right? So first proposal, it talks about a sequence number, events, sequence number. Nope, that also doesn't look like that. But again, just with writing the specmd or other state to disk, never trust the LLM to do what it's supposed to do. Always check and recheck and fix it up until it's good, and then you can continue. So for compact conversation, the plan is, or the way I approach it is, if this says 20% until compaction, I start writing the task summary MD file like a madman, and I make sure it's perfect until the context is full or the file is in a good state so I can continue the work. And once I'm done with this, I just quit the session, open a new session, and tell it to read the spec MD again and the task summary. And hopefully, with a good enough task summary MD, you're back in a state where you can continue the work that you did before. Alright, so for the final section of this long-ass video, I'd like to show you how I work with Claude in an existing code base. My money-making endeavor is Spine, a 2D skeletal animation editor, and runtimes for various game engines. You basically create characters or anything you want to animate in the editor via bones and meshes and all that good stuff. Animate those things, and then export them to a runtime format. And then we have a bunch of runtimes for specific languages, on top of which we build integrations with engines like Unity, Unreal, Godot, Hakes, plain Android native apps, iOS apps, and so on and so forth. We regularly release new versions, and in between versions, the runtime code responsible for loading and rendering exported skeletons changes. And we have a reference implementation, which is also used by the editor, called Spine libgdx, which is a Java-based implementation of the runtime. And the changes you see here between version 2.2, 4.2 and 4.3 beta need to be ported to all the other language ports. That is C++, C, C#, Dart, Swift, and so on and so forth. And as you can see, the single change set between those two versions is quite big. While individual files might not have that many changes or just cosmetic changes, like in this case with the switch. Other files might be entirely new and big and nasty and contain a lot of math, like this one, for example. And porting that over is tedious, very tedious and very error prone. So I spent a couple of nights figuring out a good workflow, a reproducible workflow with Claude that is as token and turn efficient as I can make it. And it turned out that essentially I'm using Claude as a new instruction set architecture. It just doesn't have fixed opcodes. Your prompts are your machine code or language in which you write your program that Claude then executes. And I'd like to show you how I do this. I've created a bunch of tools to enable this. The first one is called LSP CLI. And what it does is, let me demonstrate. Let's say I take the Spine libgdx folder, the reference implementation, and I want to generate kind of like a database of all the symbols defined in the source code of Spine libgdx. So I can do this with LSP CLI. It will install a Java LSP locally if it's not there yet, completely isolated from your LSPs in your VS Code, and give it a directory and the target language, which is Java in this case, and it will go through all the Java files in the directory and output the symbols to a nice little JSON file, which looks like this. A little header, what language we are using, and the directory where the source file's in, and then an array of nested symbols. So for example, this animation class here, I think it doesn't have nested symbols. Oh, it does. Timeline. Oh, it actually does a lot. It has a lot of nested classes. So the output from the LSP CLI is basically the types, their location, what kind of type they are, their range within the file, which is super nice because Claude can use this to directly read just the lines it needs for a specific type. Preview of the first line of that type, extracted Java docs for the class, and then it also has the children with the members like the fields and the methods, and also the inner types should be in here. Let's see, yeah, for example, mix direction is an enum defined inside of animation, and so on. So you might wonder, why do this? Well, The reason is for Claude to get at a symbol like a class or an enum, it needs to go through your code base. So why not help Claude and first create a map of your entire code base? And as you saw, this is a pretty big code base and took almost no time to generate this. And now Claude has all the information it needs to pinpoint where a type is, what it's composed of, if it has inner types, what the signatures of things are. And this is brilliant because Claude can use a command line tool called JQ, which allows it to query this like a database. So we save Claude from going through the code base manually, so to speak, with ls and glob and grep and rip grep and so on and so forth. So that's the first part. Optimize the way that Claude can find stuff in the code base. This is generated for both the reference runtime, so spine libgdx, and whatever runtime I want to port to, say spine C++. The second tool I built is a little extension called VS Claude. It's on the marketplace, you can use it. This basically installs an MCP server with Claude. I'm not a big fan of MCP servers, most of them are useless, but this is the only way to make this sane. And then Claude can call into the MCP server to open up files and diffs, which is amazing because my workflow is usually pick one of the Java files, open it up in the editor, open up the diff in fork, and then open up the target files, that is the .h and .cpp file, for example, if I port to C++, and then start manually going through each line and porting that over painstakingly to C++. Now I want Claude to do most of the porting for me, but I also need to review the port because it needs to be perfect. So instead of having this multiple windows setup that I used to have, I now let Claude just open up all the files inside VS Code, so I can more or less watch it work and correct any errors it makes when it ports a thing. Okay, so those are tools I created to make this workflow possible. And the workflow is expressed in port.md. Before that workflow is executed by Claude, I generate a porting plan, which basically generates the spine CPP, spine libgdxing, and then creates a file that lets me keep track of the porting status. So that has a metadata field that says from which branch or commit to which commit do we want to evaluate the change set in the reference implementation in spine libgdx. It says where the runtimes are. It says what the target runtime is, in this case spine CPP. And that is all the information Claude needs to know where it can find all the files needed for porting. It can query this with JQ, so the context isn't poisoned. And then I generate an array of porting items, if you want. That is, for each Java source file, I have a list of types that are defined in it. I list them just briefly, not the full details, because Claude can look that up in the big fat LSP JSON files later on. But I give it enough details to start working, which is the porting state. Are we done with this? If yes, we can skip this and move on to the next one. The candidate files, meaning the files in the target runtime we port to, that Claude should work with, modify if they exist. If they don't exist, this is empty. And a single Java file can contain multiple types, so this is the reason why this is an array. Okay, so this is all the ground truth data that Claude gets from me as a one-time setup step when I start porting changes from the reference runtime to the target runtime. I basically just run generate porting plan, which takes the runtime directory, the two commits, and the language we want to port to, and it spits this out. And once I have this, I can start Claude danger. Oh, we're in the wrong directory. Let me open a new terminal. So Claude danger. And now I can just tell it read port.md and execute it. And port.md is our program. Port.md gives Claude all the information it needs to know what the porting plan looks like, so it can query it with JQ. It tells it about VS Claude and the LSP JSON files. And it tells it how to compile a single C++ file for testing. So after all of that information, I specify the workflow. And this is basically a program. And Claude is the computing, how do you call it, substrate that runs this code. It has a step setup where it's instructed to read the metadata from the porting plan, which it does here. Just that field, so it doesn't get poisoned. And if you look at Command R, Command E, we see that it does exactly that. So it gets the port MD in here, which it needs. Then it executes JQ to fetch the metadata. So only this is in the context, not the entire porting plan. Then it reads something else. That's the next step. Once it has the metadata, it tries to read a target runtime conventions file. That conventions file encodes all the coding patterns and styles we use in the target runtime. And this is not handwritten, it could be, but this is also generated by Claude. And it's part of the workflow. If this file doesn't exist, then just generate it using task agents in parallel and figure all this out and then write it to the target runtime conventions MD file, which is very nice. So now Claude not only knows where to find symbols, but it also knows how we work in this target runtime in terms of memory management, RTTI, access modifiers, custom collections, and so on and so forth. So everything I as a programmer working with this target runtime know is now pretty much encoded in here. And the final part that it generates is the porting notes. I've already ported some stuff, so this now has content. While we port individual types from the porting plan, we take notes of observations. Like in C++, we don't have the toString methods. Methods with matrix 3 aren't ported from Java to C++. And as I keep porting, this fills up with new observations. And every time Claude ports a new thing, or every time I start a new session with Claude using this workflow, it will read the metadata, so it knows where everything is. It will read the conventions, so it knows how to work within the target runtime when porting. And it will also read the porting notes, which will tell it about special cases, edge cases that we need to be mindful of when porting. So, and if you look at the context here, we are still in Control R land. It reads the conventions, it reads the porting notes, and then it opens up all the files that we're about to port. In this case, the next type to port was, whoopsie, sorry. The next type to port was this one, event. It opens up all those files for me that are involved in porting. So this is the Java file, the current state. This is the existing event.h and event.cpp, which might or might not have been ported yet in full. And then I also get the diff of the Java file to see what changed. And I see only the documentation changed, and this changed from private to package private. So this is great. And as in an old text adventure, Claude following the portmd. So it read all the metadata, it read the conventions, it read the porting notes, and then in a loop, it finds the next pending type from the porting plan JSON via JQ. It also checks if there's candidate files in there. The generate porting plan can automatically fill that up using the data from the LSP JSONs. And once it has collected the next type information, it opens up the Java file and the Java Git. And if the candidate files exist, it also opens up those candidate files. So those are those 4 files up here. And then it stops and asks me if I want to port this type. And I say, hell yes. And it will start filling up its context with the additional info it needs. It needs to read the full Java file. It doesn't really have to. It could use the location range from the porting plan or from the spinelibjx JSON to just read the lines that make up the type. And if the target file exists, it also reads that. And for large files, it needs to read that in chunks because we need the entire file in context, and it's not acceptable to only have parts of that in file in the context. We also try to read the parent types if they exist, which is also in here in the porting plan. Let's see, hierarchy, subtypes, supertypes. I forgot what it's called. Anyways, it would be in here somewhere. Or actually, it would be in the CPP thing. Parent types, 9. Hierarchy, nope. Subtypes, I forgot. It would be encoded in the LSP JSON files, what the type hierarchy is for a specific type. And we need that to port it. So it pulls in all that data. And if you look what it's doing here now, so it reads all the files and then it reads the parent files. It read in the Java file. It read in the .h file and .cpp file of the candidate, from the candidate array. And then it also reads event data because it saw that being a type mentioned in the Java file. It didn't have to reach into any of the JSON files because it could construct automatically the paths. So it also reads in the corresponding C++ file of the dependent type. And then it starts porting. And this is basically just following the conventions. And if the target file doesn't exist, create that and open that up as well with VS Cloud, with the extension. In this case, we already had those files. Then port incrementally, blah, 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 yada, yada, ensure 100% functional parity, and update the Java doc, JS doc, Doxygen, whatever, based on the Java docs. And in this case, it found that the C++ version of event had renamed methods. So originally in C++ we had getInt value, and now we have getInt, because in the Java version, where is it? We also have getInt and setInt and so on, and not getInt value. So it changed that up. And it also changed it in the implementation file, in the C++ file where the actual implementation is. It opened up the, it compiled it just to make sure that it didn't fuck up. And then it opened up the diff of the changed file. And this is so much better than doing all of this by hand. And it's reproducible. And it's token efficient because only the things it actually needs for porting are in its context, and it can focus on that really well. I can now say, mark this as done. And now in our porting plan, you will see this pending switch over to done. It uses JQ for that. There we go. And now it queries the next pending type, and away we go. So again, the big takeaway. Your prompts, or in this case, my workflow description, is your programming language. Your JSON and MD files are your state. And your program basically manipulates the state on disk and queries it to do the work, just like a regular program, except super slow compared to a proper CPU. But it gives you the flexibility to express workflows like this in natural language. And it's very helpful, as you can see. I ported this without any manual intervention apart from review. If it fucked up the port, or if the file was more complex, I would intervene and help it port over parts more efficiently, or in a way that's more in alignment with the conventions. I might also just go in here and code things up myself if I feel like I can do this faster than Claude would do, or better than Claude would do. And this is the way you have to think about this if you use Claude code as a coding buddy on an established database, on an established code base. You need to give it all the information, but just enough information to complete the task. And the task description should probably be a workflow with steps. And it should have checkpoints with you to review its work and not continue unless you confirmed that the work so far is okay and it can continue. I think this is the only sane way to do something like porting. If you try to single shot this, good luck. There is no chance you will get anything out of anything of value out of that. But with this workflow, I can work through those 68 files in about a day and port this over, this change set of 5,000 changed lines and modified lines. I can port this over in a day instead of 2 weeks what it used to take me. So yeah, the big takeaway from this section: Claude Code is a programming language. Your prompt is your program, and your files on disk are your state that you can query and update. And you need to make sure that you're token efficient, so Claude doesn't get confused by superfluous bullshit like this IDE injected crap, and can focus on the task at hand and have enough tokens left in the context window to do its work efficiently without getting confused or without starting to hallucinate. Plus, have the human in the loop, which is yourself, and add yourself to your program, so to speak, as a control mechanism. And with this kind of workflow, you actually will arrive at a code quality that probably mirrors that of what you would have gotten if you did it by hand, just faster. So let me close out. That's about all I can share with you. If you're interested in things like setting up a new project, I would suggest you just look at all the information that's out there about that. Working on greenfield projects is pretty easy. You start by speccing out a plan and then implement a first draft of that, and then continue updating everything. We already kind of talked about this. The other thing I would like to tell you is that I found MCP servers to be very useless, at least at the current stage. Most of them will just poison your context with superfluous tokens and information that confuse the LLM. You want to control this. You want to know exactly what's in your context, and you want all the information to be just minimal enough for Claude to be able to complete its task. Most MCPs don't care. They just shit out a shit ton of content into your context, and it's not working so well. The only MCP server, apart from my VS Cloud integration that allows it to open up files in VS Code, the only other one is Playwright or Puppeteer, depending on what I'm working on, to do front-end development, which allows Claude to observe browser contents, basically, and manipulate them. So it can iterate on front-end code and styles and stuff like that. Any MCP that pulls in information from a database about a framework or, I don't know, does ad hoc stuff, code indexing, blah, 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 that never works for me. This very simple LSB-based, JSON-based database generation, so to speak, that Claude can autonomously query with JQ any way it sees fit, is much more efficient, both in the creation step, because this takes seconds and I can do it over and over again and never touch it if I'm happy with it, and in the query step, because Claude can just pick out exactly that information that it needs. This is so much better than anything else I've tried, and I can only recommend you use something like this yourself. What else is there to say? You need to understand your code, whether it's generated by LLM or Claude. If you don't do this, you're gonna be in a world of hurt. And giving it a loop, either like this one I defined here, where I am the one that verifies the outcome and tells it succeeded, or whether you give it tests that it can use to judge whether it succeeded. You need something like that in order for Claude to not bug you every few seconds about new input. That said, Claude generates terrible tests. It often just mocks things, which is usually not what you want. And even if it doesn't mock things, if it runs into test failures and resolves them, it will usually basically remove asserts or soften them up so much that they don't assert anything. So your tests become useless. I would suggest to treat tests generated by Claude as first drafts, just like anything else, and you need to manually review them to check whether they actually test what you want them to test. It will still save you a shit ton of time generating those first drafts, but I strongly suggest to not skip the reviewing part and the making it actually useful part. Otherwise, you have 100,000 tests, some of which fail randomly, and you have no idea why, and your CI is just gonna kill your vibes. So yeah, that's about it. I guess the parting words will be follow not me necessarily, but follow these people. I'm working with them together on Vibe Tunnel. Peter is an old friend of mine, and he does crazy stuff with LLMs. And then Armin of Flask and Sentry fame, he's also doing a lot of interesting things. He recently posted his own talk on agentic coding, which I highly recommend you watch. Those two aren't frat boys, which means they don't just post low quality slop with regards to agentic coding, but actually share insightful information that you could possibly work into your own workflows. Yeah, that's about it. Thanks for watching. I know this has been long, but I hope this was valuable.